Okay, so hopefully, I hope you guys look at problems like these as more fun because they're more like puzzles than they're like boring drill problems. But anyway, so we got this thing called a fractal, and maybe you've heard of them before. It sort of takes a pattern and then keeps repeating the pattern in smaller and smaller increments, in a sense, until it turns into kind of this cool looking snowflake-ish thing. So that this one here, the idea is it's called the Koch Snowflake, and it may be the very first fractal. And so what Koch did was he started out with an equilateral triangle, and then he removed the middle third of each triangle. So maybe I can even do this. Let's see. Sweet. So he got rid of the middle third of each triangle, and then he'd replace it with another kind of equilateral-ish triangle, but only two sides of it, right? So that's how you get from step 1 to step 2. Then he does it again, and you get to this missing step 3, and then he does it again, and you get this snowflake right after it, which is pretty amazing how quickly it turns into that. So you can only imagine how detailed the next one would be. Okay, so let me erase this. So we're supposed to come up with a sketch of stage 2. So let's see, how can I do this? Let me do this. I'm going to snip this picture right here. Actually, let me zoom in first. Let's go to 200%. Alright, so I'm going to snip this part. And I'll just draw it right on here. So is my custom pen white? Yeah. So I need to get rid of the middle third of each of these sides here. So 1/3 missing from each side. That one might be a little too big. You get the idea. There we go. Almost there. There, now all the middle thirds are gone, roughly. And I need to add in these equilateral-ish looking things. Each one is 1/3 the length of what the side was before. Whoops. That wasn't good. This way. That way. This way. There we go. Alright, and there's my picture of stage 2. So I'm going to copy this. Come back to here. Let's zoom back out. And paste. Boom. Here's part A. Oh, now I can't write anything. Great. Oh, go figure. Alright, let's see. Stage 0 has 3 edges. Stage 1 has 12. How many edges does stage N have? Well, I wanted to. Okay. There we go. Of course, now it won't erase. There we go. I don't know what it's doing. Got a mind of its own. Oh, and the A appeared. Alright, so B. Stage 0. Let's make a table here. Stage 0 has 3 edges. Stage 1 has 12 edges. Stage 2, if we count them, has 1, 2, 3, 4, 5, 6, 7, 8 on this part. Then there are 8 more here, 8 more here, 8 more here, 8 more here, and 8 more here. So that's 1, 2, 3, 4, 5, 6 times 8. That's going to be 48 edges. Maybe you can tell I'm multiplying by 4 to get from stage 0 to stage 1, by another 4 to get to stage 2. I'm going to end up multiplying by another 4 to get to stage 3. And the reason, let's erase this here. The reason is, remember, this used to just be 2 sides. But look at what happened to this side, right? I erased part of it, and now one side turned into 1, 2, 3, 4 sides. Whoops, right? This side, what used to be 1 in the previous stage, turned into 1, 2, 3, 4 sides. This side turned into 1, 2, 3, 4 sides. So every one side that existed before is now 4 sides. So it makes sense that it's going to be multiplied by 4. So the 0th stage had 3. The first stage had 12. The second stage, or let's do 3 times 4. Second stage had 3 times 4 squared. So in this case, this is a little confusing, so I apologize about this. The nth stage in this case, since we're saying stage 0 is really, that's not the greatest, but the nth stage, in fact, let's just do this. Stage. Now we don't have to confuse it with a terms. So the nth stage is going to be 3 times 4, and notice the stage number and the power are the same. So 3 times 4 to the n. Okay, perimeter. Let's see, C, perimeter of stage 0 is 3. Okay, so let's look at stage 0. If it's 3, then each side has to be length 1. Okay, what's the perimeter of stage 1? Well, this would only be 1/3 the length of 1 unit, right? So that means that this one's 1/3, this one's 1/3, and this one's 1/3. So in all, each 1 unit from before has turned into 4/3 now, right? So this one's going to be, S1 is going to have a perimeter. Let's do perimeter of S1. So the perimeter of S1 is going to have 3 times 4/3 units now, right? If every 1 unit turned into 4/3 units, then 3 units turns into 3 times 4/3. And the perimeter of stage 2, well, I'm going to take all the sides that I had, and every side is now 4/3 times longer, right? So the nth stage is going to have perimeter 3 times 4/3 to the n. Now, we can actually get stage 1. Stage 1 is going to have perimeter 4. The next one will have 4 times 4/3, so 16/3. Right. Does the completed snowflake have finite perimeter? Well, here's the perimeter for the general, right? So it's asking what happens when n goes to infinity to the perimeter. Well, notice here, that's bigger than 1, right? If I raise that to a massive power, like 1 billion, that number explodes. So this one does not exist. It goes to infinity, right? So divergent. Completed snowflake, which would be n equals infinity, completed. I'll do that in quotations. Snowflake has infinite perimeter. What about E? E asks, is the area finite? And it turns out the area is finite. In fact, if you think about it, let's say that, let's take this stage right here. If I draw a big box around it, you should be able to tell that as these stages keep developing, I'm going to build more around this one right here, you know, and then those will get even more detail in there. But the thing is, it's not getting any bigger than this shape right here. It's not actually getting outside that region. It's just filling in the gaps around it. So even though it's got an infinite perimeter as it keeps developing, it's all contained within this box. So since this box has finite area, this has to have finite area. It can't expand beyond the box. So this is kind of an interesting example in that it's got infinite perimeter, but finite area. Now, I'm not too worried about whether or not you can prove it has finite area. There is a way to do it, but I'm not too worried about it. So I just kind of wanted to show you that.